Hey guys, welcome back to AeroSafe. My name's Erica, I'm a flight instructor in Central Kentucky, and here on AeroSafe, we look at the weather from the perspective of a general aviation pilot. Maybe the airplane you're flying is not certified for flight into known icing. We're flying light piston aircraft, we can't get above the weather, and sometimes we can't get around it. Maybe you aren't even instrument rated, so you really are focused on looking at areas of VFR weather. We're gonna look at weather products available today on 1-800-WeatherBrief.com. We're gonna use the Weather Brief checklist that is available at gilbertaviation.com/aerosafe, free for your download. This checklist walks you through all of the 91-103 pre-flight action requirements, and the second page goes over all the weather reports and forecasts that you want to look at before you go on any flight. Using these resources, we are going to look at areas of VFR weather, areas of IFR weather, and then we'll also kind of discuss the hazards that exist in both of those areas. All of this is done to help you become a more informed, knowledgeable, and confident pilot when it comes to weather and weather-related decision making. If we refer to the Gilbert Aviation AeroSafe Weather Brief checklist, the first thing we want to look at is surface analysis and charts. So on 1-800-WeatherBrief.com, you'll log in, and at the top you can access the weather charts, and we'll pull up this surface analysis. The surface analysis gives us an idea of the pressure systems and frontal systems that exist across the continental US. This is important because these fronts and pressure systems are what create all of the weather that we're going to see. Further, by looking at the surface analysis chart, you can have an understanding of how the weather might change in the next couple of days. Add to that the prog charts, which are forecasts of the surface analysis. You can really get an idea of what pressure and frontal systems will be in and around your area and how that will affect the weather relative to your flying. Up in the far northeast, we have a high pressure system. High pressure is typically associated with good weather, though it may be fairly low visibility and low surface turbulence. But it does look like from this chart, there may be some good weather up there. As we move south over the Carolinas, we see some low pressure systems and a couple of fronts that have come together for an occluded front. A stationary front extends from the coast of North Carolina down and around through the Atlantic to Florida and all the way into Texas. So fronts are defined by which air mass is advancing. A front is a boundary between two air masses. Typically one is warmer and one is cooler. We define the front by which air mass is advancing, and if neither is advancing, then it's a stationary front, so that front's not moving. There's also a warm front over the Atlantic. Where these stationary and warm fronts combine, we get what's called an occluded front. What that means is there is a mass of cold air that has advanced onto a warm front. So you have cold, warm, and cool air all coming together. And typically where we see occluded fronts, we see some of the worst weather. The occluded front here is depicted with a dashed line, which means that it's a frontalysis, which means that it's weakening in strength. And I actually have seen that over the course of today. The system is weakening and the weather is improving. It's not totally depicted here, but this is going to be generally high pressure in the Midwest area, though there is some precipitation going on. The isobars here are the gray lines. They depict areas of contiguous pressure. Kind of like topographic map, the lines on one of those maps depict areas of the same elevation. The closer together the lines are, the greater the pressure gradient. The farther apart they are, the lower the pressure gradient. When we have high pressure and low pressure, and the difference is great and they're close together, we can anticipate strong winds because the air wants to reach a homeostasis in terms of pressure. The depiction here shows isobars that are far apart. In this case, we could anticipate light winds because this pressure difference is over a large area and it isn't a strong pressure difference. So that gradient overall is small. The air doesn't have to move very fast to reach an equilibrium or homeostasis. We've got a lot going on in the western part of the country. We see low pressure over North Dakota and Montana, some lows over Wyoming and Utah here, and some highs, a mix of different pressure systems here. None of them look particularly strong, so they're somewhat isolated systems. The yellow or orange dashed lines are troughs. Troughs symbolize an area, an elongated area of low pressure. Low pressure is rising air. The column of air is moving upward, and that is one of the ingredients for convective activity or thunderstorms. In order for a thunderstorm to occur, we need lifting action, a sufficient moisture, and an unstable lapse rate. And so here we see that trough and the cold front here kind of creating that little area, that little line of rain. Okay, so that's our surface analysis chart on September 17th, 1200 Zulu. Now we're going to look at the interactive map on 1-800-WEATHER-BRIEF. The layers that I have on right now are Metars and TAFs and the radar. Just at a quick glance, we can get an idea about which areas of the country are going to be VFR versus IFR. We see dots on the screen, and those are depictions of weather observation stations, typically at an airport, and their color and the amount that they're filled in represents their flight category and sky coverage. Green dots represent VFR as a flight category. Now, VFR flight category is different than VFR weather minimums in different airspaces. Typically, when we think about VFR weather minimums, specifically in reference to class Echo at below 10,000 feet, we've got 3 statute miles of visibility. We need to be 1,000 feet above clouds, 500 below, and 2,000 feet horizontally from clouds. That's different than the flight category for an airport. For an airport to report VFR as a flight category, they need a ceiling greater than 3,000 feet and visibility greater than 5 miles. Important to remember that a ceiling is only a broken or an overcast layer, not scattered or few. For example, up here in Omaha at Upley Airfield, we have a green dot, but it's filled in. The fact that it's filled in means that they do have a ceiling, an overcast layer. But because it's green, we know that overcast layer is going to be above 3,000 feet, and it is. We've got overcast at 17,000, broken at 14,000. Now let's chat about how just because an airport is reporting VFR, that doesn't mean that it's inherently safe. Here we've got some pretty strong winds. Further, if we look, we see that the weather is going to deteriorate. Stronger winds are forecast, and we see rain showers in the area. And that's probably because of this little line of storms here. So if I push the play button, we should be able to see how those storms are moving, and they are moving from the southwest to the northeast. They're going to come and create some problems up here in Omaha for just a split second. Down here in the southeast along the coast, we do have the remnants of a little bit of a little weather system that has rolled through and is continuing to roll through along the coast. We're feeling it today here in the central Kentucky area. Just at a quick glance, you see that this area, the weather will not suffice for VFR flying. We do have some red depictions, which means the airport is reporting IFR. IFR is a ceiling below 1,000 feet or visibility below 3 miles. It's not great weather right now in Raleigh and predicted to get worse. Strong winds as well. For most people, the overcast layer and the visibility is going to be a no-go. You add to it pretty strong winds, and depending on the orientation of the runway and how much of that wind has a crosswind component, you'd have to really consider if that were in your personal minimums. So this whole area here, as a result of that system and the low pressure and the occluded fronts that exist, that would be definitely a no-go for VFR pilots. IFR pilots would need to be mindful of some other hazards, which we'll dig into here shortly. Tulsa has a special observation. They're reporting broken at 1,600 feet. Winds are 130 at 7 knots. Between 1,500 and 1,600, they're expecting a broken layer at 2,000, and that is right now, and we do have that. And then at 1,700, which is in an hour and a half, they're expecting the scattered layer at 5,000, and it's going to improve from there with light winds. This is a perfect situation for those of you who are instrument rated or working on your instrument rating with an instrument instructor, a CFII. A day like this is a great opportunity in Oklahoma to fly some actual instrument conditions and fly some instrument approaches. The weather is warm enough that you shouldn't have fear of icing. It's 24 degrees on the ground, so standard lapse rate, you'd have to get pretty high before you were concerned about icing, about 10,000 feet or so. It's predicted to improve. I think that's the biggest thing here in Tulsa. When you're looking at doing actual instrument flights, honestly, any flights, you want to be sure that the weather is predicted to improve. Of course, forecasts aren't always accurate, so you have to be mindful of that. Let's look at Idaho Falls. Metar report from 40 minutes ago, winds 090 at 12 knots, so an easterly wind at 12 knots, 10 miles of visibility, scattered at 65, overcast at 8,000. This layer right here is why the station observation, the depiction is a solid green circle, so it's VFR, but there is a ceiling. Somewhat low temperature dew point spread. Temperature is 12, dew point is 8. And they are expecting showers, thunderstorms in the vicinity, scattered clouds at 5,000, cumulonimbus, but VFR. This is an example of just because there's a depiction of VFR, that doesn't mean it's safe. Winds are not particularly strong until we get into 700 Zulu tomorrow, which should be late tonight. But the cumulonimbus, we don't need to be flying anywhere near cumulonimbus clouds. The FAA advises that we remain at least 20 nautical miles away from a cumulonimbus. Realistically, we need to be at least 10 miles for every 10,000 feet of vertical development of the clouds. Up here in the far northwest, we see marginal VFR and even some low VFR as depicted by the magenta in the flight category. Low IFR means there's a ceiling less than 500 feet or visibility less than a mile. Only one of those conditions needs to be met, and we see it here with the overcast at 400. So we've looked at the surface analysis, we've looked at the Metars and some of the TAFs. Let's look at the SIGMETs and AIRMETs and see what's going on. I'm going to turn on the convective SIGMETs first, and this highlights all those problem areas that we've already looked at, except we didn't look at Florida. This convective outlook along coast and moving inland along the Carolinas. They're moving from the southeast at 25 nautical miles per hour, and the tops are above flight level 450. So you would definitely want to stay at least 50 miles away from that guy. Give yourself plenty of margin and not be near him. The convective outlook is saying that the conditions exist in the future, that we expect somewhere within this little bubble there's going to be some convective activity. So really, as this system moves northwesterly and westerly, the area is going to move that way, and those hazards and conditions are going to move with it. There's also some convective outlooks along the Gulf Coast and Florida, and some actual active SIGMETs along the Keys and eastern part of Florida. We've got convective SIGMETs along Texas, Colorado, into Wyoming and Idaho and Utah. All of those areas I would avoid. I've written in my personal minimums that I do not fly into convective SIGMETs. There's no reason to, especially when you consider, this one on the coast is embedded. You cannot see the cells, so you can't fly around them. And if you don't have onboard weather radar, most of us like piston airplanes do not have, you have no way of knowing where these cells are actually right now. These radar depictions can be as old as 15 minutes from the time the satellite takes the image, sends it, and bounces between all the different computers and satellites and through the internet in the way that it needs to. With the rate that these thunderstorms move, that could be the difference between having an okay flight and having a life-ending flight. We'll turn off the SIGMETs and we're going to turn on the AIRMETs. We'll look at Tangos first. Tango T for turbulence. That also includes low-level wind shear and high surface winds. In this area here in Kentucky, Virginia, West Virginia, we have low-level turbulence, high-level turbulence, and low-level wind shear. Airspeed loss or gain of 20 knots or more below 2,000 feet AGL. So I would avoid this area. Wind is from the east, 9 knots gusting to 17 knots, 10 miles of visibility. There is rain. It's overcast at 1,600. Wind is going to get stronger. Ceilings are going to lower throughout the day. So I would not be flying around Beckley today, even with this isolated information, let alone being in the convective outlook and the SIGMET moving that way. We'll turn on AIRMET Sierras now. AIRMET Sierras are issued for IFR conditions or mountain obscuration. So you can think of this AIRMET Sierra because you cannot see. We've got a whole bunch all over the country, and they are around those areas that we've already talked about. With that remnant of the little tropical storm over the coast of the Californias here, we have a mountain obscuration and the IFR AIRMET. Absolutely IFR conditions there. We have another one here from Kansas stretching down to Mississippi, covering eastern Oklahoma and Texas. We talked about that area. That's definitely IFR. It's important when we use these weather products, not that we just understand what they're telling us, but we need to understand how to use these products and depictions to enhance our decision making. As a VFR only pilot, it's pretty easy to see an IFR AIRMET and go, "Ooh, nope, I'm not flying today." Sometimes these AIRMETs may linger a little longer than they need to, but on the whole, these AIRMETs are there for a reason, and so you need to trust them and listen to them. As an IFR pilot, then comes the question, all right, I see this AIRMET, I am instrument rated, so this isn't inherently a no-go situation, but I need to think about, am my instrument current? Am my instrument proficient? Is this an airport I've flown into before? Is there terrain that I'm familiar with around the area? Are there approaches that allow me to go visual with the current conditions? Are there reasonable alternates in the area that meet the alternate requirements and my personal minimums for alternates? Are there outs here? Are there plans B, C, and D to a place that I can safely land in visual conditions? So again, we use these weather products not just to get information, but we need to take the next step and think about how do we use this information to make a decision. We'll look at the Zulu now. This time of year, surface temperatures are still pretty warm. Icing is not a huge concern for us. As we move farther into winter, it's going to become a larger topic of discussion, and it's going to ground a lot of us for quite a few months, so be prepared with a plan to stay proficient in other ways. This line that comes down from Canada into Arizona is depicting a freezing level at 12,000 feet. Freezing level is the lowest altitude at which the air temperature is freezing. So that means it's warmer below that and it's colder above. Now, when do we experience icing conditions? It's when we have air that is at or near the freezing level and we have visible moisture, meaning clouds, fog, precipitation. The combination of freezing air and precipitation can create icing on our airplane. You can think about it like a freezer. We see that this icing AIRMET begins at the freezing level, which is between 9,000 and 12,000 and goes up to 21,000 feet. The one over here in the Nebraska area starts at 13, goes up to 25, and over here in the southeast starts at 14,000, goes up to 26. You would have to look at where the freezing level is along your route of flight. There are some very tall mountains in this area, so there's a chance maybe you have a turbocharged aircraft. Now you have to consider, when I fly above the mountains, am I going to be in freezing temperatures with visible moisture? Because then you're going to accumulate icing. Let's look back at our checklist here. We've looked at surface analysis, SIGMETs, AIRMETs, and Metars and TAFs. A lot of the charts that we're about to look at are based off of modeled data. So the meteorologists take observations of data, they put it in the algorithms, they put it through the computer, and then they get outputs of likely conditions. They are pretty accurate, not always though. The only way to really know what conditions exist right now, as seen through the eyes of pilots in an airplane, are pilot reports. When pilot reports are given correctly, they are assembled into the data and they're published so that we can see them to improve our understanding and knowledge of the situation and allow us to operate more efficiently and safely within the national airspace system. Most of the PIREPs we see are in the areas that we've already talked about. There's one in particular I want to look at. When they're outlined in red, they are urgent. Yes, and this one is due to low level wind shear. Loss of 20 knots during the climb. We see lots of reports for negative icing, negative turbulence. Most of these are going to be bases and tops reports. If you were going on an actual flight, you would want to look at the PIREPs along your route of flight. Many of them are going to be from airliners. You don't want to see the type of airplane and disregard it because they do often give reports during climbs and during descents in the thousands of feet where we are. So they are important to look at to have a real clear understanding of actual conditions as they exist. Alrighty, so we've looked at the PIREPs. Let's look now at our weather charts. Both of those are accessible down here in the bottom right of the weather charts page on 1-800-weatherbrief.com. Cloud coverage depicts not only the amount of clouds that we see and the thickness of that layer, but it also depicts icing AIRMETs and mountain obscuration and IFR AIRMETs. For example, over here in North Carolina, along the coast, we see overcast at 600, tops are at 39,000 feet, but above that it's clear. So if you can get up there, it'll be a really nice flight. We talked earlier about eastern Oklahoma, overcast at 3,000, tops at 5,000. That is a great area to practice some instrument flying. All we have is IFR AIRMETs, so I don't see any other hazards in that area. So that area there would be great opportunity to do some actual instrument work and fly some actual instrument approaches. Safe, high ceilings for shooting approaches, low tops to get above it, and no other hazards. This, again, is a really great area for some instrument work. So again, to reiterate, we need to understand what this chart is telling us. Different layers of clouds. We see coverage of the layers. We see data points that give us bottoms and tops. We've got AIRMETs for mountain obscuration and icing, but we have to take that to the next step and understand how are we going to use this to make decisions. We don't use any one product alone to make decisions. We've got to look at all the products together to get a really comprehensive understanding of what's going on as a whole. When you have tops that get into the tens of thousands of feet, you can assume it's convective activity. But as soon as you start seeing tops at 20,000 feet, 30, 40, 50,000 feet, know that that's going to be convective activity. Look, tops to 35,000, 33,000, 26,000. All of those data points are showing the convective activity that we already know is there. Precipitation chart. This chart tells us a lot. We've got precipitation going on. These depictions here are thunderstorms. The little green triangles are rain. Yellow lines are fog. Purple shaded areas are IFR. And then we also see depictions of low visibilities. Depictions of the visibilities correlate with our marginal VFR, our IFR, and our low IFR. VFR here is just white. They don't need to add the green, but marginal VFR is depicted by blue, the flight category reporting points, right? And so that's between IFR and VFR, a ceiling between 1,000 and 3,000, or visibility between 3 and 5. Red is our depiction of IFR in terms of flight category. Here it's pink, and magenta is our depiction of low IFR, and here it's purple. So this is somewhat corollary. They're correlated here. This chart shows us our winds. Up here in Nebraska, we see really strong winds. The black portion of the barbs indicates the steady state wind, and the red is the gust. If you think of the barbs as the fletching on an arrow, so the feathers on an arrow are on the side of the arrow that it's coming from, right? The arrowhead is the direction the arrow is going. Think about these wind barbs in that way. So here it's coming from the south going to the north. We've got 5 plus 20 knots of wind, so 25 knots of steady wind, gusting to 35. Very strong winds in Nebraska today. We've pretty much covered everything. Surface analysis charts. We looked at the fronts and the pressure systems across the US, and then we looked at how those frontal and pressure systems are affecting the actual weather. And we did that by looking at the Metars and TAFs to see the areas of VFR weather and the areas of IFR weather. Next, we looked at SIGMETs, AIRMETs, and PIREPs to understand what hazards may exist within both of those areas. Lastly, we looked at cloud coverage and aviation surface forecast. Those all pretty much solidified what we already knew and figured out from the other sources of information. The last step here, if you're going on an actual cross country, is to call 1-800-WEATHER-BRIEF and get an actual weather briefer to go through this information with you so that you can ask some questions and figure out if there's anything that you missed or any holes you know you have questions about and you just want to talk to a real person and figure out. You could also call your trusted CFI who has weather knowledge and get some information from them about whether they think it's a good go or no go decision. And if you do go, what do you need to be mindful of? How do you need to plan for how the weather might change while you're en route to your destination? Again, this AeroSafe Weather Brief checklist is available for free to you online at gilbertaviation.com/aerosafe. Have you given a PIREP before? If so, what information did you give? Let me know down below or ask below how to give a PIREP, and I'd be happy to send some free AeroSafe swag your way. Thanks so much for tuning in, and I look forward to seeing you next time. Bye.